So 7.6 was actually split into two different parts. We're going to do day 2 and also move into 7.7 for rational exponents. And one other thing you should have for this particular lesson is you need to have this exponent table filled out completely. So at this point, this should be completely done. And what you're doing here is you're just taking these numbers on the side here and raising them to the power of either squared, cubed, fourth, fifth, or sixth power. And don't worry about the other stuff that's on the other side. What you're doing is just taking that number and raising it to that power. And you get pretty big numbers in the end here. You know, we have like almost 3 million down here. A lot of times, though, we'll be seeing some smaller numbers that we're going to be working with today. But I'm going to show you how to use this chart in the lesson today. So make sure you have this handy and kind of reference this back and forth. Okay, so some new notation we're going to talk about today has to do with fractional exponents, or they call them rational exponents. These mean the same thing. Same thing here. So there's actually a different way to write this, right? So instead of writing the square root of x with a little 2 there, like we said before, you can put a little 2 there, or the cube root of x, or the fourth root of x. There's another way to write this. So these two things are going to be the same. Over here, we actually have inverse operations. So if you want to get rid of something that's being squared, we take the square root. If you want to get rid of something being cubed, you take the cube root. So these are opposites, right? So these two things here are opposites, or inverses. Opposites. So they undo each other. This is going to be a new way to write a square root of x, or cube root of x, or fourth root of x. And what you can do is you can write this as a fraction. What you do is you take the base here, x, keep that the same, and we're going to get rid of this radical sign, the square root here, and we're going to actually write this as a fraction exponent. And what you do is you take the number that's here and you put that in a denominator. Now this is a whole fraction. It is also in the exponent only. And then the number that goes on top is technically the exponents inside here, but in this case it's a 1, so 1 goes right here. So the square root of x is the same thing as taking x to the 1/2 power. That might seem kind of weird and look weird, but this whole thing here is an exponent, and it is small, should be written small in the upper right-hand corner of this letter, of this variable. So using the same kind of logic, the same thing that this would be written as would be the same thing as x to the 1/3. Doesn't like when I write 3s. 1/3. Again, the power here is 1. So just another way to rewrite this. And then we're going to keep filling this out. Fourth root of x would be x to the 1/4. And we can keep doing this. So this is the exponent here. We're going to go to the 5th power. We have x to the 6th, x to the 7th, x to the 8th. And then we'll fill out the other middle column here. This would be the 5th root of x. That's how you say that. And the same thing would be saying x to the 1/5 power. And then we have the 6th root of x, or x to the 1/6. Again, same exact thing. 7th root of x, x to the 1/7. You get the idea. 8th root of x, x to the 1/8. So I think we're going to start to transition in using this notation, but they mean the same thing. We already practiced kind of using this one to get rid of powers. This is another way to get rid of the power. So here's our exponent theorem. When b is greater than or equal to 0, so here's b here. We're talking about positive numbers. We're not talking about imaginaries in this case. And n is an integer. So we're going to have 2, 3, 4, 5, 6. Has to be greater than 1. Then we would say b to the 1 over n is an nth root of b. So this is like saying the same thing. The nth root of b is the same thing as b to the 1 over n. As long as this is a positive number and this is a integer bigger than 1. So this part here says write out powers on the blank sheet of paper, which we should have already done. And I want you to have that just on hand as we do some of these problems. So let's start using the chart. Example 1, determine the positive real square root of 36 using the chart. Now you might already know what the square root of 36 is, right? I mean, you might look at this and say square root of 36. Oh yeah, I know that's 6. I'm going to show you to use the chart with that. So let's go back and look at it. So what you do is, remember, square root. Oh, maybe I should write that out too, rather than just writing 6. Let's go back here. Square root of 36 is the same thing as 36 to the 1/2 power. Pretend there's a 2 here. So then you can look at the chart and see, okay, my 1/2 power, you would go ahead and look 1/2, go down to 36. This is how you do it. Find 36. Then you read to the left. It's 6. Even though you already knew that, I'm just kind of showing you how to use the chart. Second example, determine the positive real fourth root of 16 using the chart. So the fourth root would be saying the fourth root of 16, which also means it's 16 to the 1/4 power. Then I would look at the chart. You could also put this in the calculator, but I'm just trying to practice using the chart. Okay, so fourth root, it's 1/4 of 16 is right here. Read all the way to the left. The number is 2. So that's how you use the chart. Again, you could put this in the calculator to get the same answers, but I want to practice using the chart to hopefully do some problems without using the calculator. All right, the next one we will use the calculator because we have to get a decimal. Example 2a. Approximate all the real solutions to x to the 5th equals 177 to the nearest thousandth. So that would be 3 decimal places using a fractional exponent. Okay, so we have x to the 5th equals 77. So what we're going to do is we're going to get rid of the 5th power by using a fraction exponent. So to undo 5 here, we were used to doing like the 5th root, like this, on both sides. But instead of doing that, I'm going to raise both sides to the reciprocal power. So this is 5, technically 5/1. And I'm going to raise this to the 1/5. Do the same thing on this side. And that's something that you would put into the calculator to get the right answer. This would go away. I don't know if you noticed, but you actually have 5 times 1 and 1 times 5 on the bottom, top and bottom. The 5s would cancel. You just get x, or x to the first. And this part you can put into your calculator. I'm going to see if I can do it on my phone. So you should be able to. Let me try it. Yeah, as long as you have the exponent feature on your calculator, which in my case it's like an x to the y power. 1 divided by 5. So if you're using the graphing calculator, you just hit 77, then hit the little caret button. Looks like this. And now that will bring a little box up here, a little blank spot. And you just hit 1 divided by 5. Use the division symbol. So I end up getting 2.383. And then we're going to round to 3 decimal places. So that 3 is going to round up to a 4. There it is. Notice you'll get the same thing as if you used the 5th root of 77. You can do that as well. But right now we're just using fraction exponents. So there is a huddle to try, and then we're going to move on to something new. Some of these you're going to try without using a calculator. Just use a chart. These ones here, 1 and 2. These ones you'll use a calculator, and then down here you're solving them, which I'll show you how to solve them real quick as well. I think there's not really much left. Let's do some of these ones. So you're going to find all real solutions using fraction exponents. And then now they want us to round to the 100th. So it goes 10th, 100th. That's 2 decimal places out. Okay, let's try some of these, and then you do the rest. So if we have d to the 3rd equals 14, I'm going to get rid of the 3rd power by raising it to the reciprocal power, which would be 1/3 to both sides. So 14 to the 1/3 power. I got 2.41. That's rounded to 2 decimal places. Part B, you're going to subtract 6 on both sides first. Bring down m to the 5th equals 3. Now we're going to raise this to the 1/5 power. Same thing over here. Again, these will cancel out. Get m equals, put in the calculator, we get 3 to the 1 divided by 5. I got 1.24, which would round up to 25. All right, part C, I would get rid of the 2 first by dividing by 2. V to the 10th equals 12. Get rid of the 10th power by doing 1 over 10. 10 over 1 and 1 over 10 are gone. V's by itself. Another small answer, I do believe. 12 to the 1/10 is pretty small. A 1.28. Make sure you're getting the same answers as me. And the last one, divide by 3. This will give us x to the 4th equals 10 raised to the 1 over 4. So hopefully they're not too hard for you to figure out. And these cancel out. Do we already have 10? I guess we didn't have 10 yet. 10 to the 1 divided by 4. 1.77, but then it's 8 after that, 1.78. So that's part of the huddle I helped you with. So we'll move on to the next couple parts here, a couple examples, and then we'll be done actually with the lesson. I'm going to do a really quick proof as to where this comes from. It's going to literally take like 1 or 2 steps, and then we'll be done with it. So proof, by definition of the nth root, b is an nth root of x, if and only if you remember this wording from last time, b is an nth root of x. That only happens if you have b to the n power equals x. We did this with numbers before, but now we have just letters. So b is an nth root of x if b to the n equals x. So let's suppose that b equals x to the 1 over n. All right, I'm going to go ahead and rewrite that. So b equals x to the 1 over n. My first step is what I'm going to do is to get rid of this to solve for n. I'm going to raise this to the reciprocal power, 1 over n. I'm sorry, n over 1. It's already 1 over n, so I flipped it around. And you do the same thing over here. It's a very easy proof because we're solving this for x. As long as you do the same thing to both sides of the equation, we're good. So as you can see, 1 over n and n over 1, right? If you were to multiply them out, you would get 1 times n, which is n. The bottom would be n times 1, which is also n. Over here, we have b to the n. It just goes to b to the n. That doesn't have a power at all. It just has 1, so you're just multiplying by 1. And then finally, we have b to the n equals what would happen here. N divided by n crosses out, so we just get x to the first. And so we just proved that it is b to the n equals x. So then if you want to try to solve for b, it's equal to x to the 1 over n. So it does work. You see the fractions just canceling each other out because they're reciprocals. So one other thing we can do is if we have more than just a number of 1 on top, so far we've been dealing with just like x to the 1 over whatever, right? We can have any number up here. I'm going to show you how to use that in the chart as well. So here's the 2 properties. The rational exponent theorem. For any non-negative real number x, talking about positives, and we have to have positive integers m and n, then we can use this property. So if you have x to the, say, like 5 over 4, what you can do is you can first take the top number and write it on the outside, put it in parentheses, and then just make it 1 over n. So it's kind of like you're just taking a fraction like 5 over 4, and you're saying that, oh, this is the same thing as saying 1 over 4 times 5. It's the same idea. That's what's going on up here. Right here. Which is the same thing because 5 over 1, you would put them back together to get 5 over 4. So that's one option. And probably the most important one that we're going to do. They call it the nth power of the positive nth root of x. Not that you need to know the words here, just this property and how it works. So these are the same thing, and you're allowed to do that. The other thing you could do is instead, you could take that 1 over n and put on the outside, and instead do x to the m first. So it actually doesn't matter which way you do it. So in this case, if we had 5 over 4 as the power, you could write this as 5 times a 1 over 4. It's the same exact thing. So we're going to practice using probably this property the most. Not too often using the second one, but just know that they are the same thing, and you're allowed to do that. As long as you meet these requirements. Non-negative real number and positive integers m and n. So we only have 2 examples left, and the rest are huddle. So I think I'll do a huddle or two with you as well. All right, example 3, simplify the following by hand. So I'm going to show you how to do this with the chart. So what I'm going to do here is I'm going to take 64. I'm going to separate the 5 over 6 by putting the 5 on the outside. So that would make this a 1 over 6, parentheses set, to the 5th power. So what I'm using is this first one here. All right, so let's go ahead and simplify the inside of the parentheses by using the chart. 64 to the 1 over 6. So if I bring up the chart, we're looking at 1 over 6. Here it is. Find 64, read across, and that is the number 2. Okay, so the inside of the parentheses is the number 2. So that's what takes care of this part. And then we still have this 5 sitting out there, so we have 2 to the 5th. So the way we read this now is we're going to look at the number 2, where we left off here, and we're going to go to the 5th power. So you see x squared, x to the 3rd, x to the 4th, x to the 6th. We just go to read to the right until we get to the 5th power, which is 32. And that's your answer. If you were to put this entire thing into the calculator, you would get the exact same thing as 32. So let's try another one. 81 to the 3 over 2. So it's 81 to the 1/2. Try this again. And then we're going to put the 3 on the outside. And then do the 2 steps using the chart. 81 to the 1/2. So we got to find the 1/2 power. Here's 1/2. Go down to 81. Here it is. Read across. It's 9. So this here inside becomes 9. But we still have the 3rd power because we only took care of the inside part, this part here, right here. Now we have to do 9 to the 3rd. So we left off at 9. We need to go back to the 3rd power, which is 2 across here. So 9 to the 3rd would be 729. All right, the last one, I will do the reverse. I'm going to take out the fraction first and put that on the outside and see how that works. Okay, we're going to do 8. Instead of writing 1 over 3, I'm going to put the 2 here and then put the fraction of 1 over 3 on the outside. Let's see how that works. So this is just going backwards. Now we're going to start the number 8 and find the 2nd power, which you might even know 8 squared. You might not have to look at the chart for that one. So what is 8 squared? That should be 64. So you look at the chart, 8 going over to the squared one, which is the first column, 64. So this is 64. That takes care of the inside. Now we're going to do to the 1/3 power. So we're going to find 1/3, which is this one here. Find the number 64. Here it is. Read across. The answer is 4. Which really means, I mean, this expression here means, what number to the 3rd power gives you 64. And that's 4 times 4 times 4. There's 3 of them. And that's your answer. All right, the last one. Solving the following equations for the indicated variables. All right, so we have x to the 1/2 power equals 5. How do we get rid of this? We're going to do the reciprocal. So I'm going to raise both sides to the 2 over 1. 2 over 1. It's the same thing as before. These will cross out. We get x by itself. Now we have 5 to the 2nd power, which is 25. Pretty simple. All right, part B, we have 2 times x to the 1/3. We're going to first divide both sides by 2. Get x equals, or x to the 1/3 equals 8. And then we're going to use the reciprocal power again. Raise this to 3 over 1. Again, the 3's cancel out, so do the 1's. We get x equals 8 to the 3rd power. You can put it in the calculator, or you can use the chart. It doesn't say whether you have to use the chart or not, but 8 to the 3rd power would be 8, and it's squared 3rd, so 512. And the last one, get rid of the 5 by dividing by it. Now we have x to the 3/4 equals, this would be 8. Again, no different than what we've been doing. So we're not using the chart this time. We're just getting rid of the 3/4 power by flipping it to the 4/3. 4/3. So these cancel out. I get x equals. So we can actually do this with a chart, or you can use the calculator. In this case, it doesn't matter. I'm going to do 8 to the 1/3 and then to the 4th. So 8 to the 1/3 would be, let's look at the 1/3 power. Here's 8. That would read across to the number 2. So right now it would be 2 to the 4th. And then we go 2, read over to the 4th power. Right there it is, 16. So x would be 16. And that should be it for this lesson here. You have some huddle to do. These ones you can use a calculator if you'd like. Pretty simple. And then solving some more complicated ones. I think I'm going to solve one of these before we go, and that way see if you have any questions, or at least 1 or 2 of these. I think the most of these that you're good with, but I think maybe the last 2 are the hardest kind. So we'll do that. All right, if we have p to the 3/2, I'm going to flip the fraction to 2/3, do it to both things. And then again, these cancel out, just like you'd expect. But now we have a fraction raised to another fraction exponent. The way you do this is you're going to give the 2/3 to both things in here, the 64 and the 125. So I'd write it like this: 64 to the 2/3 over 125 to the 2/3. It just has to go to both numbers, the numerator and the denominator. And then you can use a chart or calculator. I don't think it particularly says in this one, does it? Now you can use a calculator. But I'm going to use a chart just for more practice. So this would be 64 to the 1/3 squared, 125 to the 1/3 squared. And as you get good at this using the chart, you can probably not have to separate break this apart every time. So 64 to the 1/3, I'm going to do this all in one swoop. We would have 1/3, 64 is 4. And then we're also going to square that. So this would be 4 squared, which would be the number 16. The bottom, 125 to the 1/3. Here's 1/3. 125, that's 5. And then we're squaring 5, which is 25. Again, if you did this in the calculator, you would probably get a decimal, but you can convert that to a fraction. This would be the answer as a fraction. So it's p equals 16/25. Okay, the last one I want to do is one that looks kind of janky here. So this is a expression that's in parentheses, so we have to get rid of the 2/3 first before moving the 1. Unlike number 8, you would move the 10 over first by adding it. So I'm going to put another big set of parentheses here, and this is going to be 3/2 to both sides to cancel these 2's and 3's out. So you get 1 plus r, no parentheses anymore. And then this side, 16 to the 1/2 to the 3rd power. I'm going to use a chart for that. Okay, here's 1/2, 16, read across, that's 4. And then we're going to what? To the 3rd power. 4 to the 3rd is 64. So 1 plus r equals 64. And then simply to finish that, subtract 1. So r equals 63 as an answer. So now you're left with doing the rest of the huddle and finishing up this lesson. And I believe there's only 2 sections left for this chapter, and we'll be wrapping it up.